Hello students, we discussed about the common digital signal process. We shall consider examples for both floating point and fixed point processes. First we speak about the fixed point digital signal process. The major manufacturers are Analog Devices, Texas Instruments, and Motorola. All of these manufacture the fixed point digital signal processors. Analog Devices offers a fixed point DSP family under the name ADSP21XX. There are many variants which come under this particular family. Texas Instruments provides various generations of fixed point digital signal process based on the historical developments, architectural features, and computational performance. Some of the popular ones are TMS320C1X, which is the first generation, TMS320C2X, 5X, and 62X. So TMS320C is a name synonymous with DSP process coming from Texas Instruments. Motorola manufactures a variety of fixed point processors which come under the family DSP 5600X. The newer families of fixed point DSPs continue to add and continue to grow in terms of their performance. But basically, the common features such as program memory, data memory, the address buses, ALUs, program control unit, MACs, shift units, address generators, all of them will be common among all the fixed digital signal process. Here, as an example, we consider the Texas Instruments TMS320C54X as an example. We can see the architecture of TMS320C54XX fixed point digital signal processor. The architecture is pretty simple. We have a separate program memory and data memory. There are separate buses to facilitate transfer of data and program. You can observe here there is a program memory address bus and there is a program memory data bus. For data memory, there are provided 3 pairs of buses which are named as C, D, and E. There is a data address generator. There is a program address generator. There is a program control unit. It has options for input-output devices. We have the arithmetic logic unit. We have the multiplier/accumulator, and we have the shift unit. The TMS320C50 family supports 16-bit data. It's a 16-bit processor. It has on-chip program memory as well as data memory, which comes in different sizes and configurations. They also include the data RAM and the program ROM, which is used to hold the code as well as the instruction and the data. 4 data buses and 4 address buses are available in total, and these are there to help in the working of the data memory and the program memory. The program memory address bus and program memory data bus, they are responsible for fetching program instructions. The C and D data memory address bus and C and D memory data bus, they are meant to deal with fetching data from the data memory, whereas the E data memory bus address bus and data bus. They are dedicated to moving data to data memory. In other words, C and D are there to fetch the operands, whereas E is there to store the final result. Additionally, E-memory data bus can access the input-output devices. There are the other computational units like ALU, MAC, shift unit, etc. Now, TMS320C54X family, the ALU can fetch data from C, D program memory data bus and access the E memory data bus. It has two independent 40-bit accumulators which are able to operate on 40-bit addition. The multiplier fetches data from C and D memory data bus and write the results via the E data memory data bus. It is capable of handling 17-bit by 17-bit multiplications. The 40-bit shifter has the same capability of bus access as the MAC. It allows all possible shifts for scaling and fractional arithmetic, such as those we have discussed for the Q format. Program control unit fetches instruction via the program memory data bus. In order to speed up memory access, there are two separate address generators, one for program address and one for data address. It makes use of the advanced Harvard architecture where several instructions can operate at the same time for a given single instruction cycle. This speeds up the operation. The processing performance offers around 40 million instruction sets per second. MIPS is the unit used to measure how many instructions are executed in unit time. Next, we speak about the floating point digital signal processor. Floating point digital signal processors perform DSP operations using the floating point arithmetic, which has been discussed. The advantage of using the floating point processor is including getting rid of finite word length effects such as overflow, round-off errors, truncation errors, and coefficient quantization errors. Due to restriction in the word length available, all these phenomena of overflow, round-off, truncation, and coefficient quantization will crop up. And floating point is a possible solution to all these problems. Hence, in terms of coding, we do not need to scale input samples to avoid overflow, or shift the accumulator result to fit the tag word size, scale the filter coefficients, or apply Q format arithmetic. All these problems can be avoided when you go for floating point processor. A floating point digital signal processor with high speed and calculation precision facilitates a friendly environment to develop and implement DSP algorithms. Because we can avoid all these steps, hence coding will be pretty easy in the case of floating point processors. So it is a more attractive option. Analog Devices provides a floating point DSP family under the name ADSP 210XX and Tiger Shark. Texas Instruments offers a wide range of floating point DSP families, in which the TMS320C3X is the first generation. It is followed by 320C4X and 320C67X families. Since the first generation of floating point digital signal processor is less complicated than the later generations, but still retains all the important basic features, we shall review the first generation architecture itself. The figure which follows will show you the architecture of the Texas Instruments TMS 320C3X family of processors, and we shall talk about its important features in brief. So here we observe the typical architecture of the TI TMS 320C3X family of processors. As you can note, we have data bus, we have CPU, we have direct memory and access, we have serial ports, we have timers, we have the different types of memories, and we have different types of ports along with their interfaces. Let's talk about the important features. The TMS 320C3X family consists of 32-bit single-chip floating point processor. It supports both integer as well as floating point operations. This is selectable. You can either go with floating point or integer operation. The processor has a large memory space and is equipped with dual access on-chip memories. The meaning of the term dual access is that at a time it is capable of referencing two operands. This is optional. Either you can go with single access or you can perform dual access. A program cache is employed to enhance the execution of commonly used codes. Similar to the fixed point processor, here also we use the Harvard architecture, where there are separate buses used for the both program and data, and hence instruction can be fetched at the same time that the data are being accessed. There also exists memory buses and data buses for direct memory access, for concurrent I/O and CPU operations, and peripheral access such as serial ports, I/O ports, memory expansion, and an external clock. The DMA feature allows the CPU to carry out its own operation and not be disturbed for the purpose of input-output. There will be a dedicated controller which is called as DMA controller which handles this operation. The C3X CPU contains the floating point integer multiplier. It has an ALU which is capable of operating both integer and floating point arithmetic. It has a 32-bit barrel shifter which is going to speed up the shift operation. It has internal buses. It has a CPU register file which has a good collection of registers. It has a dedicated auxiliary register arithmetic unit which is primarily there to compute the addresses. Because there are a lot of addressing modes and we need to calculate the address quickly, there is a dedicated arithmetic unit which will help in computing the address, making use of the auxiliary registers without disturbing the ALU. The multiplier operates single cycle multiplication on 24-bit integers and on 32-bit floating point values. The operation of multiplication on these large numbers is completed in one single cycle. Using parallel instructions to perform multiplication, ALU will cost only a single cycle, which means that a multiplication and an addition are equally fast. The all-important instruction of multiplication can be done quickly under this architecture. The ARAUs support addressing modes in which some of them are specific to DSP. For example, the circular buffering and the bit reversed addressing mode, which is used in digital filtering and FFT operations. The CPU register file offers 28 registers which can be operated on by the multiplier and ALU. The special functions of the registers include 8 extended 40-bit precision registers for maintaining accuracy of the floating point results. 8 auxiliary registers can be used for addressing and for integer arithmetic. These registers provide internal temporary storage of internal variables instead of external memory storage to allow the performance of arithmetic between registers. This way, program efficiency is greatly increased. The important feature of C3X is its floating point capability. This allows operation of numbers with a very large dynamic range in comparison to fixed point. It offers implementation of DSP algorithm without worrying about problems such as overflow and coefficient quantization. 3 important formats are supported. First one, a short 16-bit floating point format where there are 4 exponent bits, 1 sign bit and 11 mantissa bits. Second, there is a 32-bit single precision format which carries 8 exponent bits, 1 sign bit and 23 fractional bits. Third, there is a 40-bit extended precision format, contains 8 exponent bits, 1 sign bit and 31 fraction bits. These formats don't typically follow the rules set by the IEEE 754 standard, but obviously we have conversion option between this format and the IEEE formats. The TMS320C30 offers high-speed performance with 60 nanosecond single cycle instruction execution time. This equates to 16.7 million instructions per second. To go with speech quality applications, with an 8 kHz sampling rate, it can handle over 2000 single cycle instructions between 2 samples. That is 125 microseconds. With instruction enhancements such as pipelines executing each instruction in a single cycle, 4 cycles required for fetch to execution by the instruction itself, and a multiple interrupt structure, this high-speed processor validates implementation of real-time applications in floating point arithmetic. So these are some of the important features of the floating point processors. Thank you all.